In grade 5-6, we're introducing a new topic today of probability. So let's get started right on it. So the probability is the likelihood. That means how possible it is for something to happen, okay? And it doesn't guarantee it will happen. It's just thinking what it might happen. So for example, if we were talking about a sunrise, sun coming up tomorrow morning, that probability is almost certain. We pretty much expect the sun to come up, right? But if on the other hand, we're talking about the likelihood of school being open tomorrow, that's highly improbable. In fact, it's pretty much impossible. We really don't expect the school to be open tomorrow. But, I mean, something could happen. I would be surprised, but something could happen, okay? So probability is about guessing the future, essentially, okay? So let's look at some probability possibilities. So let's start with this. What's the probability of flipping a coin and getting heads? There's my head, isn't it lovely? Versus getting a tails. Let me draw a leaf on here. There we go. Okay? Well, we have two choices. When we flip the coin, we'll either get a heads or we'll get a tails. So the probability is 1 out of 2. There's two choices, 1, 2, but I can only get one of those. So 1 out of 2. Okay? Now what about the probability of a dice and landing on a certain number on a dice? So here I have a dice, and we know a dice has 6 numbers on it, right? So there's 6 numbers on a dice. So what's the probability of getting any specific number? Well, our bottom number is 6 because there's 6 possibilities. So the probability of getting a 2 would be 1 out of 6. And the reason it's 1 is because there's 1 2 on the dice. There's not 2 2s on the dice. The probability of getting a 6 is also 1 out of 6. Okay? Because there's 1 6 on a dice, etc. All right, a spinning wheel is a little bit more complicated because a spinning wheel can be set up in all sorts of different ways. So when it's talking about a spinning wheel, you're going to end up with something that looks a bit like a graph, a circle graph, or a fraction piece, okay? And in this case, we just have to count how, we have to make sure that everything on this graph is divided into equal pieces. So for example, if this is, let's make it red because this is a red pen. This is red. We'll make this one green. Lovely. We'll make this one orange or yellow. We'll make this one blue. Okay. Now, what is not true about this statement is that the possibility of green is 1 out of 1, 2, 3, 4. That is not true. The reason that's not true is because all the pieces are different sizes. So the chance of rolling and landing here is much better than the chance of rolling and landing right there, okay? So when we're talking about probability on something like this, what we actually have to do is we have to have it divided into pieces that are about the same size. And you actually know this already because we did something similar to this already with our circle graphs. Remember that? So here we go. So actually the probability, because we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the probability of landing on the blue is 1, 2, 3, 4, 5. 5 out of 12. See that? 5/12. Does that make sense? I hope it does, because obviously you can't answer me. Okay? So you have to make sure that you've got things divided up into ways that make sense or intelligent. Okay? Now a deck of cards, this one's really awesome. There's 52 cards in a deck. There's 13 cards of each type. And we know we've got hearts, we've got diamonds, we've got spades. I can't really draw a spade, but I'll try. There we go. And we've got, what am I missing? Clubs. No, that's a club, sorry. I just drew a club. This is a spade. There we go. Okay, so there's 13 of these, there's 13 of these, there's 13 of these, and there's 13 of these. But we also know that these two are red and these two are black. So when we're talking about probability, we have all sorts of possibilities. To get a black card would be 26 out of 52, or 1/2, because all of this is black. So we have to go 13 plus 13 is 26. Our total number of cards is 52. So a black card. To get a diamond card, of course, is just 13. out of 52 because there's only 13 diamond cards, which is the same as 1/4. Okay? Now, what if I said I wanted to get a king card? Well, if you know anything about cards, you know that there's 1 king of hearts, 1 king of diamonds, 1 king of clubs, and 1 king of spades. So that means we have 4 out of 52 to get a king. And I haven't actually reduced that, but I know it does reduce 1/13. Yeah. Okay? So it depends on what we're asking on how we end up dividing this up. And that's really, really important. We have to know what it is that we're asking about. A king could be a heart king, it could be a diamond king, it could be a club king, it could be a spade king. All right? What if I said, though, what's the probability of getting a king of hearts? Now that's just one very, very specific card, and it's 1 out of 52. And that's all the chances we have, just 1 out of 52. All right, so pay attention to what the question is asking you. Super, super important. Etc. means, of course, there's all sorts of things that we can do probability on. I've just given you some examples. All right, so now if we look at these pictures here, we could decide, we could ask a lot of different things here. Okay, so what's the probability of getting a tomato? We're going to treat this as one group. We're not going to treat it as individual things. But everything else we're going to treat as individual. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. We have 19 items in here, okay? So what's the probability of getting a red item? Well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the probability of getting red is 13/19. What's the probability of getting something green? Oh, looks like 3/19. I should be writing green there. 4, sorry, it's 4. 1, 2, 3, 4. 4. Okay, and then what's the probability of getting something orange? 1/19, yellow, 1/19. But we could ask other things too. For example, what's the probability of getting a red vegetable? Now it's different because we have to think about what we mean by that. So this is obviously not a vegetable, and this is obviously not a vegetable, and this is obviously not a vegetable. Some people say tomatoes are vegetables, some people say they aren't. We're going to say that tomatoes are vegetables because that's the way they're scientifically categorized. Okay? So now we don't have 19 items anymore because we're only talking about the vegetables. So this number, it's not right anymore. 19 was right when we were talking about everything, but it's no longer right because now we're only talking about part of it. So we have to recount. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So now my number is 11. So what's the possibility of getting a red vegetable? It's 1, 2, 3, 4, 5, 6, 7. That's 7 out of 11. Okay? So what you're asking is very, very important for probabilities. And probabilities, as you can see, they're written as fractions. But you can also write probabilities. You can write probabilities like this. You can write probabilities like this. Or you can write probabilities like this. These are all correct ways of writing probabilities. And it doesn't matter which way you write them, you need to reduce them. So let's say you wrote your probability like this. That's not a finished answer. You have to finish it by writing 1 out of 2. That's your final answer. Okay? You always have to reduce it to the simplest form, just like in fractions. Okay, so we were talking about circle fraction representations, and here's a great example. So some simple questions on this is, if I want to get a red, which spinner should I spin? Well, obviously, I should spin this spinner because there's the most red on that. Okay? Now, if I do not like red, which spinner should I spin? Well, I should spin this one right here because I have no chance of getting red on that spinner. Yes, this red on this one is smaller, but there's no red at all on that one. So that's a better choice for me for a spinner than doing one of the others. Okay? Now, what if I was asking the question, I don't like blue. which is the best spinner. This one is the best spinner. This one is the best spinner because it has the smallest blue piece. There's blue on every spinner, so I can't just pick one that doesn't have blue on it. So I want to pick the one that has the smallest piece. All right? Now, let's look at some other questions here. What is the probability of landing? Let's look at this graph right here. What is the probability? Actually, before we do that, let's look at this graph. What's the probability of landing on blue? 1/4. That's simple, right? They're all the same. Green is also 1/4, red is 1/4, yellow is 1/4. Now here, some of you will have stopped listening at this point, and then you're going to ask me a question in chat, and then I'm going to tell you have to go back and watch the video, because this is very obviously an important part to make. This one right here is very different. It has all the same colors, but they're in different proportions. And we can no longer now call it 1/4 because we have to have them broken up into pieces that are about the same size. All right. So now you can see I'm actually putting this together. Just get that fixed. This one is like this, like this, like this. This one's like this, and this one is like this. Now, this is just an estimate. Your pictures are going to be more specific, but we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We have 16 pieces. So green is 3/16. Red is 1, 2, 3, 4, 5. 5/16. The chance of landing on red is 5/16. The chance of landing on blue or yellow are both 4/16. Okay? Blue is 4/16, yellow is 4/16. Now, if you wanted to know, okay? So just like that. All right. So at this point, I'm going to talk briefly for the grade 6s, but grade 5s you should continue to watch because I'm going to look at your workbook pages after I'm done here. So if you shut it off now and then you have questions about your workbook, you're going to miss the explanation. Okay, now you don't just do probabilities on one thing like this. You can also do probabilities for possibilities when you're adding certain things together. So in this case, we're going to look at possible breakfasts, okay? So you have to drink, you can have juice or chocolate milk, and to eat, you can have cereal, peanut butter and honey, or oatmeal. So now we have two choices. You can either have juice or chocolate milk. You have to pick one of them. So let's say you pick juice. Let's not write with that. Let's say you pick juice. Now, what are your possible breakfasts? Well, you could have cereal, you could have peanut butter and honey, you could have eggs, or you could have oatmeal, right? That's your possible breakfasts. Now, but that's not all of your possible breakfasts. That's only what happens if you pick juice. Now, what happens if you pick chocolate milk instead? What are your possible breakfasts? Well, the thing is, these options don't change, do they? You can still have cereal, you can still have peanut butter and honey, you can still have egg, you can still have oatmeal. See that? So when we're done here, you can have, I'm going to trace it for you. We can have juice and cereal, we can have juice and peanut butter and honey, we can have juice and egg, or we can have juice and oatmeal. We can have chocolate milk and cereal, we can have chocolate milk and peanut butter and honey, we can have chocolate milk and egg, or we can have chocolate milk and oatmeal. So we actually have 1, 2, 3, 4, 5, 6, 7, 8 breakfasts here. There are 8 different things you can do for breakfast. Those are how many combinations you have. This is a direct question you have from your book, so pay attention. How many possible combinations do you have? There are 8 possible combinations. You can do any of these. So you can have juice with all of the options. You can have chocolate milk with all of the options. You have to account for every single option. So now we could ask some questions about this. How many of your options involve you eating oatmeal? Well, 2 of them do. Remember, this is a whole option right here. That's an option, and that's an option right there. Both of them together, not just the oatmeal part, the juice and the oatmeal, the chocolate milk and the oatmeal. So you have 2 options where you eat oatmeal. How many options do you have where you have juice? Well, every single one of these options have juice with them, don't they? It's either juice and cereal, juice and peanut butter and honey, juice and egg, or juice and oatmeal. So you have 4 options with juice. Okay? And the reason we make these trees like this, which are really fun, they're called tree diagrams, is because they help us quickly and easily identify what it is that we are trying to accomplish. Okay. All right, so let me talk about the workbook pages here now. All right. So grade 5s, this is your workbook pages. Right here, you're looking at the bag. You've got 5 green, 3 red, and 2 yellow. So there are not 3 marbles in that bag. There are 5 green marbles, 3 red marbles, and 2 yellow marbles. So first you have to think of how many marbles are actually in the bag. And then you have to do your fractions. Here, you're talking about boys, you're talking about girls, you're talking about boys with glasses. So pay attention. This one right here, this circle graph, this is exactly what I was talking about. This is not a 4 on the bottom. Do not write a 4 on the bottom because the pieces are not the same size. Here, you're just answering the questions based on the things. So, for example, chips has 2 sections here. See that? Pretzels has 1, 2, 3 sections of this graph, or the circle diagram. All right. And then at the bottom, you just answer the questions. All right. Grade 5s. Grade 6s, we've talked about the probability of dice, the probability of coins, the probability cards, but in this case, these cards are not a deck of 52. It's just these cards right here, these 3 cards. They don't want you to answer questions about a whole deck of 52 cards, just those 3 cards. These ones here, you have to pay attention because the probability of doing a 3, oh, that's easy. There's only 1 3. It's right there, right? But what about the probability of an even number? Well, that's an even number. And that's an even number, and that's an even number, and they're more even numbers. So you got to make sure you're paying attention. And remember, prime numbers are numbers that you can't divide smaller. So I'll give you an example of a prime number. 7 is a prime number because you can't divide it any smaller. You can't make a 7 smaller by dividing it by 2 or 3 or something like that, okay? A 7 can only be divided by 7, which just means it's still 7. It hasn't gotten any smaller, okay? And then this is the tree diagram exactly like what I was just telling you about, except this isn't about breakfast, this is about lunch, okay? But it's exactly like what I showed you, so I'm not going to actually give you any more instruction on this. Okay, good luck.